trusses, space trusses. A space truss is a three-dimensional counterpart of the plane truss. Is the three-dimensional counterpart of the plane truss described in the previous section. The idealized space truss consists of rigid links connected at their end by ball and socket joint. The idealized space truss consists of rigid links connected at their ends by ball and socket joint. Whereas a triangle of pin-connected bars form the basic non-collapsible unit for the plane truss, a space truss on the other hand requires 6 bar joints at their ends for the edge of the tetrahedron as the basic non-collapsible unit as shown in this picture. Non-collapsible space truss 1, 2, 3, in the ground or in connection with members only. With the members we should have 1, 2, 3, 1, 2, 3, 6 members. Consider this picture. The two bars AD and BD joined at D, this point, requires a third support of CD as shown here, this support, to keep the triangle ADB from rotating about AB. In this picture, the supporting base is replaced by bars here. The previous description is about this. 3 more bars AB, BC and AC to form a tetrahedron not dependent on the foundation for its own rigidity. We may form a new rigid unit to extend the structure with 3 additional component bars whose ends are attached to 3 fixed joints on the existing structure. In the example, which is shown in this picture, we may form a rigid this figure, the bars AF, BF, and CF AF, BF, and CF are attached to the foundation and therefore fix point F in space. Likewise, point H is fixed in space by the bars connected to the point, these three bars. The three additional bars C, G, F, G, and H, G are attached to the port G and point C, F, and H, and therefore fix G in space. These three points. We see now that the structure is eternally rigid. The two applied loads shown will result in force in all of the members. A space truss formed in this way called a simple space truss. Ideally, there must be support such as that given by a ball and socket joint at the connection of a space truss to prevent bending in the members. As in riveted and welded connection for plain truss, if the center line of joint member intersect at the point, we can justify the assumption of the two force member under simple tension. Statically determined space trusses for a determinate statically space trusses, there is a equation that say that m plus 6 should be 3j. J is the number of joint and m number of members. If m plus 6 is greater than 3g, this is independent equation and truss is statically indeterminate. Internally with redundant method. And if m plus 6 collapsible structure, method of joint also can be used in the space method of joint. The equation is sigma f equals to 0 and method of section. sigma m equals to 0. Besides sigma f equals to 0, which has 3, sigma fx 0, sigma fy 0, and sigma fz 0, such as the plane trusses. Choosing the appropriate section is important, and calculation for the supports are important in the section method. The next section is frame and machines.